Hey guys, I think everything's good here. Everybody's been asking me about how to make these motors. So I have this one, it's all apart. What I'll do is, a lot of people are asking me how many turns and stuff, and like how many turns of the trigger coil is, but it's really not necessary to know how many turns, it's more to know how many ohms they are. So I'm going to show that. Here's the actual circuit that'll go on this motor, and I will get this motor running here on this video, and I'll show you how I do that. This is half of a motor. The whole circuit is pretty much here, and it's simplified. It's so anybody can read it. This is a transistor, base collector, emitter. Here's your battery. It's a capacitor. We'll measure the coils, and it's not really wired like this, and you'll see when I start it how I figure out the proper wiring. This is the trigger coil, and yes, that's all there is to it. There's nothing else on here. People think it's a little bit simple, but it really is simple. One diode on the output, and you can put a cap here if you want. You don't need it though, just to collect your back spike. And yes, if you don't have this hooked up, it will blow your transistor up. So if you want to put protection on your transistor with a neon, you can go right ahead. But if you're uncertain, just use one transistor. These transistors are all paralleled. As you can see, they are all connected together in parallel. It's kind of shitty lighting here. Let's set this up better. It's not too bad. But yeah, this is going to be a long video. This is for the people that are asking how to make these motors. This is exactly half. Once you have half of it on, then you can do like this motor is. See, I've got one of the drive coils off here because I blew it up and I'm repairing it. But that one gets connected in series with this one, and these two are in series. And there's 6 transistors per side. They are all paralleled. These 6 are in parallel, and these 6 are in parallel. And that's the trigger coil. So here, I'll just measure the ohms here on this, because you can have any combination of ohms. It's just a matter of how many. Like if you have a higher impedance coils, you're gonna have to run it at a higher voltage to make it work. I always try to make these motors work with a low voltage and still have a lot of power, because the more power, more amperage you put into these motors, the more power you get out of them, and the more back you get out of it. It's the amperage that produces that back spike. It is exactly like this, the rotor here. There's 10 poles. They're all alternating. You can see the drive coils are just like this. One's on the north and one's on the south. You can put them side by side, make the wiring a little easier. I have it like this because it's more balanced on the bearing when it's running. And you can see the trigger coil exactly like that one is. It's identical to this. Jewelry the same. I'll check the impedance here of each coil. See that? They should be pretty close to the same, but 0.7, 0.6. Write that down. Let's put 0.6 here. 0.6. Do the next drive coil. They're very close to each other. 0.5. Now this one here is going to be a high impedance coil. I don't know what size of wire this is. It's really thin though. It's in the 30s for sure. $61 ohms. And like when you have that many ohms, you'll run pretty much all the transistors with that. I've not found a transistor that doesn't turn on with these coils. $61 ohms. So as it is right now, I don't even know if these, like which ones to wire where. Well, I kind of do because I color coded them here earlier. But what I do is I'll just grab a jumper wire. Stuck to the magnets. I just get a jumper wire, connect them together. Like this is probably going to be the wrong one, so I'll do this on purpose just to show, right? And I'll actually grab a battery. There's a 12-volt battery. Should have some wires ready. Okay, here's one that'll work. It's in series with a light bulb already, which will be good because it acts like a resistor. So you can see it really doesn't have much power like that because it's fighting itself. It doesn't want to move, right? So, if you think that's wrong, switch it up. And now it should be much better. You can tell now it's working fine. That's what you want to see. It has torque and it tries to push itself away when you put it where it should be, like, right? So we know that's right. You can actually solder that wire. I've been gone since January. This stuff has been on the bench. A lot of people have been asking me about it, so I figured I would make this video. It's gonna be long though, so hope you guys are interested to learn how it works. Don't use this stuff. I don't know what I did with my other little solder, but all I have is this stuff here that doesn't have any flux in it, so I'm gonna use this. Don't use this stuff, it'll fuck your wiring right up. I'm using it just for this video so I can solder this shit together and not have any bad connections. Monster solder. So now that's there, right? So now what I want to do, okay, so I know the emitter goes to the battery. And that's here. It's this wire. You guys see that? Right? So this goes to the battery. This stuff here connects to the battery. This is my output circuit. It's the same as this right here. It comes the positive output here. See, here's the negative. It's connected right here. Goes out to this black wire. And the positive is connected directly to the cap right there. And goes out to that black wire. Black wire with the white stripe is the positive. So this goes to from the negative with this diode connected to it that goes to the positive of the capacitor, because you're connecting to the back spike, so you want the positive, like you want to be hooked to the negative to create your positive back spike, because the back spike is going to be opposite of what you put into the battery. Most people building pulse motors already know that, and you only need the one diode. You don't need this capacitor. So, and it's very simple circuit. This will get connected to the battery. I always have big caps on the input that are in parallel with the battery, and it gives a huge spike. It helps a lot to make it go a lot smoother and faster, more torque. So now I know these coils are wired in series properly, so you'll be not needing those right now, those connections, and I can just use these. I know this was a positive here and this was a negative, but it doesn't matter. You can hook up either or, and then you figure out your timing with your coil here after. So what I'll do is the collector from the transistor goes to the negative right here. And from this, you want to connect your positive. This blue wire goes to the positive of the output with the diode on it. You can have your diode right here, or whatever you want to do. So this one gets connected with that. You can solder that together. Because if your timing is off, you could just adjust it with your trigger coil. So now that input for the negative is done, and it will also give me the positive for the output. Just with that. This, see, now the positive goes directly to the capacitor or to your negative wire coming out, right? You don't need anything else. And this can be soldered directly to your input. So all there is to it. That part of the wiring is done. That's your positive going to the battery here, and the negative going to the battery. The negative connects directly to the emitter. The positive goes directly to the coil. And I have these caps are parallel. So the negative of the cap goes to the emitter, and the positive of the input cap goes to the positive, which goes to the battery up here. So that part is done. So now, when you want to check your timing and stuff, is the time you want to hook up your output wires to another battery or something that'll catch that back spike. Because if you don't do this step, you'll blow your transistor up. So I'll hook it up to a battery. I have this battery here. One of the white wires, the positive. And as it is right now, I should be able to just hook up this trigger coil and it'll run. But it'll run in a one, like it's set right now already, the coil. And it can move for timing purposes. So it'll run slower in one direction than the other one. See, and I've already had this hooked up, so the yellow wire I use for the base, because that's more of a positive, and the blue wire was hooked to the negative, right? So I will hook it up backwards. just for the purpose of showing you guys. So one goes to the emitter and one goes to the base. And I'm just going to hook these up here with alligator clips directly onto the base of the transistor, or the emitter here. That's what I'm doing on this one. And this will go to the base. Find another alligator clip here. So that base is open down here. I can hook it right here. So when I hook it up to the battery here now, it should actually run. I won't use that resistor. So here's the negative in. And here's the positive. Maybe the timing's off so much. So all I'm doing here is switching it around the trigger coil. There you go. It's running. See, like, it wasn't starting up because the base was going to the emitter. It needed to be the other way around. It's running. So which way here am I turning? The only reason it didn't run the other direction is because it's retarded so far this way. I could feel it when I was turning it. It was resisting it. So that's going in clockwise. Can't stop it even. Turn it counterclockwise. One good thing about having a cap on your output is it will save your transistor till the back spike gets really high, then it'll blow it. Yeah, okay, I think it needs to turn the other direction. That was counterclockwise. It's clockwise. Yeah, it's better. man, like this thing has torque. It'll break your finger. It's quite a bit of power. Torque power, not just RPMs. If I remember right, I think it takes about 2 amps to run it. 1237 on the input. .3. Oh, you guys can't see that. Fuck. That's the output battery after I turn it off. They were both fully charged, so no wonder it's getting overcharged. 12.6. Back on. See it go up again. That's all there is to it. See, the other motor just has 2 of these put together. 2 drive circuits side by side. So yeah, that's all there is to it. Here's another look at that. For anybody who really wants to build one. Just message me if you guys got problems. I'll try my best to help you out. Like, a lot of people are concerned about how many turns the coils are. It doesn't matter. If you got higher ohms on your input, on your coils, on your drive coils, you just need higher volts to run them. Because you need to get a certain amount of amps into these coils to make these fuckers powerful. I designed these motors to actually use them for like torque, because when you torque them down, the output going to the battery doesn't change much at all, because you're putting more current into the motor, and the more current you put in, the more it charges. The trigger coil is the key to making these motors simple, because you don't need nothing else. You want your transistor to be open, full, when you're running these things. If you're starting to restrict the flow of power going into the motor with your transistor, it's not going to work very good. You won't get a very good back spike. Your transistor won't be turning off very fast. If you're trying to resist the power going into the motor, you have to do it by controlling it here or here. Or not that way, this way. Controlling it here is probably your best spot. This one or your positive. Right here. That's the way I do it on this one. On that other, you'll see in some of my videos where I'm actually charging batteries and lighting bulbs while that motor is running. That's because of actually cutting the power down on the input right here. And that goes directly to the negative. the coil, the drive coil. And I was in the process of setting up this other side seam, because this is one drive and this is the other drive. There's 6 transistors paralleled on each of them. The trigger coil was probably about 100 ohms on this one, and I'm pretty sure these coils ohm out about the same as that other motor. But I hope that helps. If you guys got problems, just give me a comment, message. Help you out as much as I can. Yeah, I don't use this fucking corrosive shit on your wires. I know better. I'm just doing it to show you guys. Well, thanks for watching. This video is pretty long, so thank you.